Hi everyone, I am Himanshu Singh and welcome to our video on heat transfer. This video is very helpful for the GATE students and I am making this video especially for the UNACADEMY STARS 2022-24 programs. So okay guys, I am going to explain what is heat transfer and how it is useful for the mechanical engineers. Okay, so in this chapter, we will learn about the how heat is transferred or how heat is moving from the one body to the another body. So main focus is our to learn about the how heat is transferring in the form of the molecules, in the form of the moving molecules from the one body to a different body. So, in the terms of that, we will basically say about the definition of the heat transfer. The heat transfer is the energy in transit due to the presence of a temperature gradient. And in this gradient, how it is very different from the thermodynamics. Because in thermodynamics also we can study about the transfer of the heat, but there we can only study about the initial and final temperature, how it is changing from the initial temperature to the final temperature, and with the help of that we can directly find the heat. But here in heat transfer we can learn about the rate of heat transfer, and also we will see how temperature distribution within the body is happening. In generally in heat thermodynamics, this inside the body we can't know how temperature is distributed. So that's why heat transfer is different from the thermodynamics. And also in this heat transfer we can know about the temperature after certain length of the time. If you want, then if there is a 10-meter length of the wire is there, in that wire, in that rod, if heat is transferring from the one point to the another point, so if we want to know on the 7 meter of the length how much heat is there, so we can only find in only in the time of mode of heat transfer. We can't find in the in thermodynamics. So here you can see we have a three mode of heat transfer. One is conduction, second is convection, and third is radiation. So one by one we will go through the all three mode of the transfer, how it is happening. Okay, so now we can talk about the conduction. Conduction basically occurs when heat travels in solid to the direct contact. One thing is very clear, when our two body is in the direct contact, then only conduction will be happen. So how conduction will be happen? Conduction will be happen due to temperature difference by molecular lattice vibrational energy and also by the free electron movement. So inside that, when you are hitting any rod from the one side, so inside that rod, molecules are slowly vibrated due to the energy. So with the help of that, that molecule will translate motion inside the rod and it is reaching towards one point to the another point. So that's why you guys know how it is slowly increasing the temperature. If you can hold the rod, so you can think at initial you are thinking that rod is cooler, but after some time you are feeling rod will be getting more hotter and hotter. Why it is happening? It is happening only due to the conduction. That's why conduction is a very major phenomena in the as a mode of the heat transfer. So now we can also see how conduction is happening. So in that case, there is a one famous scientist. Maybe you guys, everyone know who is that. That guy is Fourier. Fourier explained about the conduction, and he can explain the one formula for that, which is we are calling Fourier law of the conduction. So how it is that? So basically Fourier law of conduction is basically we can say is the for heat conduction of heat transfer is directly proportional to the thermal conductivity and the area of the body. So here you can see Q equal to minus Ka dt by dx, which is the formula of the Fourier law, which is comes as in the form of watt. Here K, what is K? K is the thermal conductivity, which is basically inversely proportional to the temperature. So how it is inversely? So basically, if we are increasing the temperature, so in that case our conductivity will decrease. So that's why we are calling thermal conductivity is the inversely proportional of the temperature. And all metals are the good conductors. You guys, everyone know all are the metal which are there. Like you can say about the aluminum, copper. These all are the very good conductor. In metals, copper have a higher thermal conductivity, but in some cases if you can say which material has the highest thermal conductivity, so in that case diamond is the higher most thermal conductivity, which is 2300 watt per meter square Kelvin. Diamond have maximum number of thermal conductivity all above the metals. But even diamond is not a metal. Diamond is a not metal. But there is a due to some crystal structure of the diamond that their conductivity is very high. Okay, so now we move forward to the convection. So convection, how it's happened? Basically, convection is happens between the two fluids. Maybe you can say it is a liquid, it is a gas. Any fluid is there. So if you can say convection is happening in the liquid, so how it is happening? It is happening basically due to the temperature difference and due to the macroscopic bulk motion of the fluid. How it is happening? If you are slowly heating any pan, in that pan if any water is there, so due to that, first due to conduction, that pan will be heated, and after that lower level of the molecules which is heated initially, then slowly that molecule going upward, and that cooler molecule will come down. So due to that way, slowly macroscopic bulk motion of the fluid is happening. So due to that, convection is happening. So in that case, basically H is the convective heat transfer, which is inversely proportional to the temperature. And you can see this H is totally dependent upon the thermal physical property. It is not dependent on the temperature, which we already saw in the conduction. In conduction, K thermal conductivity is directly dependent on the temperature, basically inversely dependent. But here, H is basically dependent on the thermophysical property of the fluid, which is density, viscosity, specific heat, and constant pressure, and bulk modular. These four criteria is very much important in the convection. So basically, convection heat transfer is governed by the Newton law of motion. You also know that Newton also give formula for the heat transfer also, for the convection also. So according to Newton law of cooling, basically it says about convective heat transfer Q is directly proportional to convective heat transfer coefficient and the temperature. So in that case, this formula is coming Q is equal to H A delta T, which is also comes as a watt. You can see there is a one example is a hot air balloon. This is a very good example of the convection. Here we can fire the gas. So with the help of that heat, that balloon is slowly blown up, and with the help of that, slowly it will getting up and down. So this is the best example of the convection. Now we can come to the radiation. What is radiation? Basically, radiation is the mode of heat transfer which does not require any medium. Only radiation is the mode of heat transfer which there is no medium is required. In previously case, in for conduction, for convection, basically mode is required. But in conduction, solid body is required. In convection, liquid and gas is required. But here there is no mode of medium is required. It is only happens due to electromagnetic wave of propagation, which is traveling with the speed of light. And for that is the very good example is sun rays coming to the earth. So you can see when summer season is there, sun rays is directly hitting to the earth, and slowly our earth temperature will increase from morning to afternoon. So this is the best example of the radiation, and this heat flux by thermal radiation is basically governed by the Stephen Boltzmann law. There is a two scientists. Someone confused in that maybe this is the same name, one name scientist there. No, this radiation phenomena is discovered by two scientists. One is Stephen and second one is Boltzmann. They both combined and come up with one law. It's very good law, which is the E is the emissive power, and which is directly proportional to the fourth power of the temperature. So we can say our emissivity and our radiation is directly proportional to the fourth power of the temperature. So here you can see in previous case we can see only one power of the temperature, but here is the fourth power. So how it is stronger? So that's why radiation is very high. That's why people are saying please don't go outside at the summer season because radiation is very high. Due to that your skin is burning. So you can see here temperature is the fourth power. That's why this kind of thing is happening because sun temperature radiation is directly hitting to the earth, and that one is the very high thing. And due to that, there is a one famous formula is coming E is equal to sigma delta T ki power 4, which is the watt per meter square. And in that sigma, what is sigma? Sigma is the basically Stephen Boltzmann constant. They calculated with the help of sun rays. they calculated this value, and this value comes 5.67 into 10 power 8 watt per meter square. Kelvin की power 4. This is very very mandatory. You guys always care about temperature की power 4. Always fourth power is required for the radiation. Okay, thank you very much for everyone for joining this video. Please like, subscribe, and comments. Provide your comments in this video so that this is very helpful for me. Thank you very much.